and welcome to the Mathly YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Hello. Let's look at contest problem set 12213, team round, problem 9. Let a sub 0 equal 1 over 4 and a sub n equal the quantity 1 plus a sub n minus 1 over 2 for all n greater than or equal to 1. Let S be the sum of the numerator and denominator of a sub 2021 when expressed in simplest form. What is the remainder when S is divided by 100? So our objective is to find the remainder when S is divided by 100. To do this, we might try some small cases like a sub 1, a sub 2, a sub 3. And we might find that we can rewrite these as a power of 2 minus 3 over that same power of 2. So we might think that a sub n is equal to 2 to the power n plus 2 minus 3 over 2 to the power n plus 2. From here, we can find a sub 2021 by plugging in 2021 for n. So we have a sub 2021 is equal to 2 to the power 2023 minus 3 over 2 to the power 2023. Now, we know that this is in simplest form because this is an even number minus an odd number, which is odd. And in the denominator, we only have powers of 2. So we know that this is in simplest form. Since S is the sum of a sub 2021's numerator and denominator, we have that S is equal to 2 to the power 2024 minus 3. Again, our objective is to find the remainder when S is divided by 100. So we're interested in this. So let's consider this. It suffices to find the remainder of 2 to the power 2024 mod 100. From there, we can subtract 3. So let's try that. Let's find the remainder when 2 to the power 2024 is divided by 100. To do that, notice that 100 has prime factorization 2 squared times 5 squared, which is 4 times 25. It's enough to find the remainder of this quantity when divided by both of these numbers, 4 and 25, because 4 and 25 are relatively prime, which means that if we know these remainders, we can apply the Chinese remainder theorem to find the remainder of 2 to the power 2024 when it is divided by 100. And from there, we can find the remainder when S is divided by 100. So let's first focus on this left-hand equivalence. We have that 2 to the power 2024 can be rewritten as 2 squared raised to the power 1012. 2 squared is 4. 4 raised to any power is equivalent to 0 mod 4. So now we can fill in this unknown, like so. Now we focus on the right-hand equivalence. Mod 25, that's interesting. Let's consider a sub-problem. So to find the remainder when this quantity is divided by 25, let's first consider the remainder when 2 to the power 10 is divided by 25. 2 to the power 10 is 1024. When divided by 25 leaves a remainder 24, but that's equivalent to minus 1 mod 25. This is important because now we can take our quantity we were interested in, 2 to the power 2024, and rewrite it as 2 to the power 10 raised to the power 202 times 2 to the power 4 using law of exponents. We know that 2 to the power 10 is congruent to minus 1 mod 25. Minus 1 raised to the power 202 is 1. 1 times 16, which is 2 to the power 4, is 16. So we know that 2 to the power 2024 is 16 mod 25. And now we can fill in this unknown. So now that we have these two equivalences, we want to use the Chinese remainder theorem at this point. So let's first consider this right-hand equivalence once more. We know that 2 to the power 2024 is equal to 16 plus 25k for some integer k. That's what this equivalence on the right means. Furthermore, for all integers k, in order for 2 to the power 2024 to be equivalent to 0 mod 4, we must have that 16 plus 25k has remainder 0 when divided by 4. That's making use of this equivalence on the left here. In other words, we can rewrite this equivalence using what we know about modular arithmetic. So for example, there are some multiples of 4 on this left-hand side. We can move the 16 over and take out multiples of 4 from both sides. We can take out a 24k, which is 4 times 6k, a multiple of 4, and we can add 16 to this right-hand side. So we have that k is equivalent to 0 mod 4. This implies that 16 plus 25k is equivalent to 0 mod 4. That's this up here. If and only if k is equal to 0 plus 4 times l for some integer l. This is making use of this line above. So we're just taking what we already know and saying different things with it. At this point, we know that 2 to the power 2024 is equivalent to 0 mod 4 and equivalent to 16 mod 25. So both are true at once. If and only if 2 to the power 2024 is equal to 16 plus 25 times 0 plus 4 times L. What we did was we took this k is equal to 0 plus 4L and substituted it into this expression on the right here, which gives us 16 plus 100L for some integer L. Now, just to be clear, it's important to note that this 0 plus 4L comes from the k congruent to 0 mod 4 that we had a couple of slides ago. It corresponds to this, while this 0 mod 4 corresponds to this equivalence that we solved for earlier. They're slightly different. Now that we know 2 to the power 2024 is equal to 16 plus 100L, we have that 2 to the power 2024 is congruent to 16 mod 100. This is just another way of writing it. These two statements say the same thing. So finally, we can fill in this unknown at the top. We know that 2 to the power 2024 is equivalent to 16 mod 100. If we subtract 3 from both sides, we have that s has a remainder 13 when it is divided by 100. And we're finally done. To recap, we noticed that our recurrence had a closed form using small cases. From there, we used modular arithmetic extensively to reach a point where we could apply the Chinese remainder theorem and determine the remainder of a quantity, in this case, S. And that's it. Thank you for listening.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.